This is lesson 19, and we're going to talk about nonlinear systems of equations, factoring exponentials, and the sum and difference of cubes. So, first of all, solving nonlinear systems of equations. When you're solving these kinds of systems of equations, it's sometimes helpful to know what the equations represent graphically. It will give you an idea of how many solutions to expect. So it's just a quick way to recognize certain kinds of equations and what graph they represent. So if x and y are both squared, if you have an equation where x is squared and y is squared, and they're both positive, then you're going to have either a circle or an ellipse. And we're going to learn how to graph those and understand and recognize the equations later on. But for now, just if you can see those two things or a couple of things happening, it'll help you to recognize that equation. If x and y are both squared and one is negative, or if xy is in the equation, x times y, then you have a hyperbola, which is a double curve. It looks like two parabolas, actually, kind of. If either x or y is squared but not both, then you have a parabola. And if the highest degree on any term is 1, the equation is a line. We've been talking about those equations already. So those are just some ways to recognize these different kinds of graphs quickly. So we're going to solve this system of equations, which first equation has x and y are both squared, so we know it's either in a circle or an ellipse, and it's a circle because when the coefficients on x squared and y squared are the same, then you're going to have a circle. So that's not something you have to know yet. You don't know how to graph a circle necessarily yet, but it's okay. Just recognize the equation. And then y minus x is 1, that's a line. So we're going to solve in the only way we can, which is by substitution. So we have for this first equation or second equation, we can solve for y and get y equals x plus 1, and then we can substitute that into the first equation. So we've got x squared plus y squared, so x plus 1 squared equals 9. So x squared plus, square the binomial, x squared plus 2x plus 1 equals 9, and then add our like terms and subtract 9 on both sides, and we have this quadratic, so we need to solve the quadratic, and we can go ahead and divide both sides by 2 to start off with, just to make it easier. And since we have an equation, we're allowed to do that. We can multiply or divide both sides by any non-zero number, and so now we can use the quadratic formula. So we'll plug that in. This will tell us the values for our x coordinates of the points we're looking for, these 2 points of intersection. Because remember, whenever you're solving a system of equations, you can look at it in 2 ways. You can look at it algebraically, which means what numbers will work in these 2 equations. You can also look at it geometrically, as in where do these 2 graphs intersect. So just about everything you're learning now can be learned in 2 ways. It can be looked at in both of those ways, the algebraic way and the geometric way. The analytic geometry is what it's called, all this graphing of things in the plane, and that was all kind of thought up by René Descartes, who's a philosopher. He did a lot of things, but this is one of the things he did. That's why the plane, the xy plane, is sometimes called the Cartesian plane, and sometimes why when we have x, y coordinates, we call those Cartesian coordinates because of René Descartes. Cartesian, yeah. So anyway, so we're using the quadratic formula to solve. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So for our x coordinates, we have negative 1/2 plus the square root of 17 over 2, well, plus or minus the square root of 17 over 2. So for our solutions, one of the coordinate pairs we're going to have has an x value of -1/2 plus the square root of 17 over 2. And it'll have a y value, we don't know yet. And then the other one has -1/2 minus the square root of 17 over 2. So we got to find the y coordinates. So we can take the x coordinate and plug it back into the easy equation, this one, to find out what y is. Well, actually this equation. So y is equal to x plus 1, so y equals -1/2 plus the square root of 17 over 2 plus 1, which is just +1/2 plus the square root of 17 over 2. So the y that goes with that x is 1/2 plus the square root of 17 over 2. The other value for y, the other y value, we could plug in that x value to find out what y value goes with that, and it's going to just be the conjugate of this y value, 1/2 minus the square root of 17 over 2. And these coordinates, these kinds of things are always going to come in conjugate pairs. You just have to make sure that you get the right x with the right y and not just kind of throw them together. And I don't want you to write the solution to this. I would never want you to write the solution to this as -1/2 plus or minus the square root of 17 over 2, comma, 1/2 plus or minus the square root of 17 over 2. Okay, you need to write both points, making sure you've got the right x with the right y. Okay, here you have the first equation, again, is that same circle with radius 3. The second equation has both x and y squared, but it has a minus, which tells me it's a hyperbola. And again, that's not something you would necessarily know how to graph yet, but we can see that there are 4 points of intersection here. So we should expect 4 different points for the solutions to this equation. System of equations, sorry. So we can see we can solve this easily by elimination. The y's go away and we have 3x squared equals 3. So x squared equals 1. So x is going to be plus or minus the square root of 1, which is 1. So we have 2 x values here, but we know we're going to have 4 solutions. And you can see that 2 of them will have the same x value, and these 2 will have the same x value. So we're going to have 2 points that have an x value of 1, and we're going to have 2 points that have an x value of -1. And even if you didn't have the graph, you could still figure this out, because when you plug in +1 into either one of these equations to find out what y goes with it, you will get 2 solutions for y. So if I take +1 and check it in the first equation, I'm going to have +1 squared plus y squared equals 9. So y squared equals 8. And if I solve for y, I take the square root on both sides, I have to put plus or minus the square root of 8, which is plus or minus 2 square root of 2. So just by plugging back in the +1 for x, I got 2 values for y. So one of the points is 1 +2 square root of 2, and the other one is 1 -2 square root of 2. Now if I plug in -1, this -1 for x to find out what y is, same thing's going to happen. I'm going to get the same 2 solutions, because -1 squared is going to be 1 also, and y squared will be 8, and y will be plus or minus square root of 8, which is plus or minus 2 square root of 2. So when I plug in -1, I'm going to get 2 solutions. I'm going to get 2 square root of 2 and -2 square root of 2. So these are the 4 points where these 2 graphs intersect. They are the 4 solutions to this system of equations, and you would need to write those as 4 separate points to show what the 4 solutions are. So we want to factor this exponential, and sometimes it helps to figure out, I mean, first of all, you're going to factor out the greatest common factor, which between 3 and 12, you know that's 3. You're going to factor out the 3. But what power of x are you going to factor out? And then what will be left on the inside? Sometimes it helps a little bit just to understand what's going on if you kind of rewrite it showing all the factors of x that you have. Okay, so thinking about how we add exponents on like bases. This first term, you've got 3, it would be, since it's x to the 2n, that means you've got an x to the n and an x to the n, because if you add those, n plus n is 2n. And then you've got plus 2, which means you've got an x squared, so x times x. So that first term, these are the factors of x that you have there. You've got an x to the n, an x to the n, an x to the 1, and an x to the 1. Because if you add those exponents, you've got n plus 1 plus 1, which is 2n plus 2. So if you can see what I'm doing, I'm just kind of separating out the factors just to give us an idea of how we decide what the exponent on x should be with the greatest common factor that we're factoring out. And then if we look at the one with the 12, the second term, what are the factors of x there? Well, we've got 3 factors of x to the n, and we have 3 factors of x, right? Because that's n plus n plus n plus 1 plus 1 plus 1, which is 3n plus 3, which is the exponent on x right there. So when we pull out the greatest common factor, what is it going to have? Well, it's going to have 2 of these x to the n's, because this one has 3 of them, and this one only has 2. So we can't pull out more than there are for either one. So we can have 2n, and then there are 2 factors of x here, and there are 3 factors of x here. So again, we can't pull out more than one of them has. So the greatest number of x's that they both have is 2, so x squared. So that's 3x to the 2n plus 2. So that's what we're going to factor out. And we will write whatever is left. For the first term, that's exactly what the first term is. So if you factor out 3x to the 2n plus 2, for the first term all you have left is 1. And then for the second term, you factored out the 3, so you have a 4 left there. And then you have x to the, you've got a factor of n left, one of these guys right here. And then you have also another factor of x that's left over, so n plus 1. Okay, here's another exponential that we want to simplify, and since we have been looking at a lot of things that involve a difference of squares, you might look at the numerator here and realize that it is a difference of squares. So it is x to the a squared minus y to the b squared. Because when you raise power to another power, you multiply the exponents. So that is actually a difference of squares, even though maybe at first it doesn't look like that. All right, so that tells me that I can factor that numerator, x to the a plus y to the b, x to the a minus y to the b. And therefore, the numerator has a factor of x to the a plus y to the b, and the denominator does too, so we can factor those, we can cancel those, and we just end up with x to the a minus y to the b. So that difference of squares shows up a lot, and you just have to be ready to recognize it when you see it. We are also now going to look at the sum and difference of cubes. So the sum and the difference of 2 cubes are factorable. If you remember, the sum of 2 squares, the sum of squares is not factorable. The difference of squares is factorable. We just did that. the sum and difference both of cubes are factorable, and these are their factorizations. They look just alike, a cubed minus b cubed and a cubed plus b cubed. The factorizations look exactly the same, except where you have, for the a cubed minus b cubed, you have a minus sign here. And for the a cubed plus b cubed, you have a minus sign here. So it's a little, I mean, I guess you can think of it that with the a cubed minus b cubed, since it is a minus, the minus comes first in that one, and it comes second in the sum of two cubes. But basically, it's something you'll want to memorize. It's very similar to a binomial squared, but there's no coefficient of 2 here. So be careful with that. It's different from that. So you want to memorize this and then be able to use it. 8m cubed y to the 6th plus x cubed. That is 2my squared cubed. So that first term, 2 cubed is 8. M cubed y squared cubed is y to the 6th plus x cubed. So this is your a and x is your b, and you are going to use this factorization. So you start out with a plus b, so that's going to be 2my squared for your a, and x is your b. And then you have the second set of parentheses. You've got a squared, so it's going to be 2my squared minus ab, so that's 2my squared x, and then plus b squared, and x is your b, so x squared. And then you can go back through and rewrite it with this first term as 4m squared y squared. And then you got 2my squared x plus x squared. So that would be the factorization of this sum of cubes. So you definitely need to know the sum and difference of cubes and how to factor that.